Hello, so this question is optimize water distribution in a village. So this question is a graph related question. So you are going to, you know, find out the minimum total cost to supply water to all of a house. So you can have a pipe between two houses, which is going to be, house one, house two with the cost J. So if one connecting two, this is also referring to two connecting ones, so it's a bidirectional. And the cost will remain the same. So this is the cost for 1 to 2, 2 to 1. But if you are having this kind of graph, imagine at this. Like four is four is by itself. So you will have to have a will for the house four, right? So yeah, this is a pretty much the whole idea. And then what you should do is imagine that you have no pipe. Imagine you have no pipe. Each house construct a well on its own. So this is going to be the current cost for the well. And then how do I build a graph? I can have a invisible house 0, and then I can say, oh, 0 to 1 is cost 1, 0 to 2 is cost 2, 0 to 3 is cost 2. Then based on this is the default one, right? Then I can traverse my pipe. I will say, oh, 1, 2, 1, 2 is 1, 2, 3 is 1, right? So now I will just based on the traversal. So the house 0 is an invisible house, and then it's not going to do anything. But when you do the traversal, you want to find out the minimum cost first. So find out the minimum cost. So 0, 1. So 0, 1 will be the first one, right? So you're traversing the first one right here, and you want to find out what is the minimum cost. I mean, both of them is the smallest one, right? So you can take either one of them, right? But if you do traverse the current node, you don't want to traverse again. Like this node has been visited, you don't want to traverse again because it's already connecting, right? So it comes here, it's one, and then the two edges, one's the smallest. I mean, both are the same, so I can come here to this node, and then my neighbor is 1, 0, 3, but 0 has been traversed, 1 has been traversed, and the cost between this is 2 and 1. You're definitely not going to pick 2, right? You definitely need to pick 3. So it's going to be this. So you just add up. You add up, 1 plus 1. So that would be the solution. All right. So the first thing is we want to build a graph. So I'm going to hash map. Here is going to be the node, and then the value is going to be another hash map. So this is going to be a source. This is going to be a destination. And then this is going to be the cost. And then just say graph. And then I will just traversing from 0 to all of the node, right? So it's going to be graph.compute. I need to initial my map. So it's going to be initial my map. And then dot put. So it's going to be 0 to I plus 1, 0 to I plus 1. I mean 0 to all of the node, right? And I is by default 0. And then the cost is going to be the what? The wheels, right? So this will be the default graph. And then I can traverse a pipe. So I would say source equal to pipe 0, destination equal to pipe 1. The cost will be the pipe 2. Then I'm going to calculate sorry. I need to calculate the cost, right? The cost from source to destination. This will becomes graph.compute if absent. So I already initialized the graph for 0. I have an initial graph for the source and destination. And literally just get a default. This is source to destination. And by default, it's going to be the maximum. So this will be the same, but it's going to be test to source, test to source. So I'm just say graph get the source. So this is going to be a key. You get a source. So where you want to connect to the destination with the minimum cost, right? So math.min. So it's going to be cost, comma, so source to destination. And then do the same thing. Destination to source with the cost, destination to source. Right. So this is a graph I built. I probably need this. I do. Okay. And then I will have to have the the record to store the visit node. And then I will have to have a priority queue to know which is the current priority. No, I need to traverse. So my index 0 is represent the node. My index 1 is represent the cost. And then I will just say offer, and then new int. By default, I start with 0. No, 0 with cost 0. And then I will just say, oh, I need to return it total cost. So while the PQ is not empty, then I will just pull the data up. And then this would be the current node equal to data 0. This would be the cost at data 1. So if the current node has been traversed, so visit contains no. If the current node has been traversed, I want to continue. I don't want to do anything else. I just add it. And also add the cost. And then once I add the cost, I need to traverse the neighbor. So graph.get or default the no new hash map. So the current node can have neighbor or no neighbor, right? So this is why we need to create an empty hash map. And then for the key set. So you get the node, get a neighbor based on your node house. The key set is always the what? The one you're connecting, right? So pq.offer new in, and this will be a neighbor. The first one is a house, and then the second one is going to be the cost, right? It will be this one. So it would be definitely something like graph is going to be used right here, get node, and then get neighbor. So this will add every single neighbor into the priority queue. But what happens if the neighbor has been traversed, right? So you want to do if the neighbor or if the visits does not contain in the neighbors, then you add. So which means the neighbor has not been traversed, right? So this will be the solution. Hopefully I don't make mistake. I do. There's plus. Okay. So for the time and space, this is space. This is also the space. The worst case is going to be all of n. You add every single house. And for the time, this is all of n. This is all of p. But when you do the priority queue, it's going to be, n log n, right? So yeah, the worst case this. All right, so if you notice, like what we are doing is we are trying to connecting node by node. So which means we can use a union find. And then once we use the union find, we apply this logic, and then it will be straightforward enough. So let's write the union find. So what I need to do is I need to create the in array for parent, and then I declare my constructor, and I take size of n, and then parent.new int n. I traverse every single index to assign my current value equal to I. So I point at myself, and then the best things for union, one is you want to union with 2 node, and also you want to know where is your ancestor. So it's going to be fine in X. So if X does not equal to parent.x, then there must be an ancestor, right? So by default, they are the same. By default, they are the same. But if they union, you want to find out the ancestor, right? There's going to be parent X is equal to find parent X. So don't make mistake like this. So this does not make sense. You can only find your ancestor. You don't want to do find X and then point at your parent. Like, this doesn't make sense. This makes sense. And then when you return X, or you can return X or parent X. They are the same. If they are not the same, you will still keep traversing. Recursions, right? It's a recursion code. And then for the union, you can do the parent at find at X is equal to parent at find at Y. So you want to find, so by default they are point at, point at the current node itself, and then if they assign, they will just, this parent Y will point at this one. So this is a trick. Like when you do the find, then you do this. When you do a union, you do this. All right, and then I need to create a union find, giving the size n, and then I will have to have the list of in array. I'm gonna call it edges, and then it's declare as array list. I will traverse the n. I'm going to build my in array, which is my edges, for all of the 0 to I plus 1. So I'm connecting the invisible house, and then my default value is going to be wheels at I. And then once that happens, I'm traversing the pipe, and then doing just add it, just to add it, right? This is a source destination cost, source destination cost. So when I do this, I want to sort it by the cost. I want to do the smallest one first. Collection.sorted based on the edges with 2 AB, so A minus B, but what I need to do is going to be the cost, sorted by cost, right? A2 minus B2. So I will have an in result, return result. And then I will just traversing my edge. So at this moment, this has been sorted. So if the two node is not connecting, you want to union. And then once you union, you want to add the cost. And then that will be it. So int x equal to uf.find edge of 0, which is source, y equal to union find.find edges 1 destination. So if x does not equal to y, they are not union. So uf.union x comma y, and then I would just have to add a cost, which is going to be the edge of 2. So yeah, so the list is already sorted. So you are definitely traversing from the lowest number first, the lowest cost first. You check, does the current two nodes are connecting? If they are, then you ignore it. If they are not, then you union and add a cost. So hopefully it passed. Okay, where is the problem? So when x does not equal to parent x, then you find this is the problem. Parent x equal to find parent x. Where is so again we shouldn't we shouldn't discard the invisible house, which is house 0, right? So when we declare the size, it's going to be n plus 1. And then it has to solve with I equal to 1, right? And then I less than equal to n. This is because we assign the index 0 for the invisible house, right? And that should be the mistake. Cool. All right. The union find the spaces all of n. Fine. This should be pretty straightforward. Based on the ancestor. I mean, the worst case is going to be, I would say log in probably. I don't know. Yeah. And for this one, union finds this is space. So worst case is going to be all of n. This is time, all of n, all of p. This is going to be all of n log n. This is all of e. I mean, it's going to be all of n. And so the worst case is going to be the sort, right? So this will be the solution. All right, see you.